Okay, guys, we're back. Finishing up part one. Says the population of a small town over 4 years is recorded in the chart below, where 2013 is represented by x equals 0. Population is round to the nearest person. Okay, so if they tell me that 2013 is 0, then this will be 1, this will be 2, this will be 3. Alright, the population P of x for these years can be modeled by the function P of x equals a b to the x, where b is rounded to the nearest thousandth. Which statement is true about the function? So if I look at the initial, which would be my a there, my initial is 0, and my population is 3,810, so I know this is going to be true. And if I look at the population, it's increasing, not decreasing. So if it's increasing, it tells me that my b has to be greater than 1. The only part where my b is greater than 1 is right here. So it's going to be choice 2. There's actually nothing to figure out except for just taking a quick look and understanding that this is an exponential function. And if exponential functions increase, this middle here has to be greater than 1. And knowing what my initial is. 17. When written in factored form, 4w squared minus 11w minus 3 is equivalent to. Now, I can go ahead and multiply 4 times 3 and then go ahead and keep plugging through and trying to solve factor and everything like that. Or I can FOIL. All right? I can look at my functions, take a best guess to see which one's going to work. The answer is 17. The 17 is choice 3. And I'll prove that to you by going ahead and foiling. Now, I understand that you're going to have to go ahead and try each one, but I think this way is easier. So we got 4w squared. That's going to be a minus 12w. That's going to be a positive w. This is going to be a minus 3. I can combine my two middle terms. So I got 4w squared minus 11w minus 3. So that gives me back to my original. Okay? The others will not. 18. Which ordered pair does not represent a point on the graph y equals 3x squared minus x plus 7? A few ways to do it. You can put it in your graphing calculator and scroll around and see which point doesn't look like it's going to be on it. Or you could plug each one of these into the equation and find out which one. So 18 is going to be choice 3. And I'm going to plug it into the equation. So remember, this is your x, this is your y. So my y is 10.25. And that should be equal to the 3 times my x, which is 1.25 squared, minus the x again, which again is 1.25, plus 7. So I'm going to go ahead, I'm going to plug that in. So we have 3 parenthesis 1.25 squared minus 1.25 plus 7. I hit enter. It is not 10.25, it's 10.43. So I know those are not equal, and they want to know which one does not represent. So that's why it is choice 3. Okay, 19. Given the following sequences, which ones are arithmetic sequence? All right, so the arithmetic sequence shows adding. All right, so which one consistently shows adding at the same rate? We got plus 2 here, plus 2 here, plus 2. Over here we got plus 2, plus 4, plus 8, plus 16. So this one actually shows multiplication, so we know it's not that one. And this one always shows adding. So it's just 1 and 3, which is choice 2. Okay, number 20. A grocery store sells packages of beef. The function C of W represents the cost in dollars of a package of beef weighing W pounds. The most appropriate domain for this function would be, and I'm trying to think here, so we got packages of beef. We're going to want positive numbers because you can't buy negative beef. And you want them to be rational, right? Something that goes on forever, you're going to constantly be getting beef. So positive rational numbers is going to be the solution to that question. 21 says the roots of x squared minus 5x minus 4 equals 0 are. So I'm looking at this, and I know I cannot find factors of 4 that would subtract to give me 5. So that means I'm going to have to use the quadratic formula. And that quadratic formula is actually in the reference tables that they give you, or your reference sheet. So here's my quadratic formula right here. Okay. So I'm going to go ahead and use that. Negative b plus or minus square root b squared minus 4ac all over 2a. Okay, a lot of work for part 2, I know, but it is a part 2, or part 1 rather, and we got to do it. So this is my a, which would be 1. This would be my b right here, and this is my c. So we're going to plug it in. So negative b, so the opposite of negative 5 will be positive 5. Plus or minus, now you could probably guess already what the answer is going to be. B squared, so it's going to be negative 5 squared, plus 4 times a, which is 1, times my c, which is negative 4, all over 2a, which is 2 times 1. Okay, this over here, this is going to be 5 plus or minus the square root of 25, and then 4 times 1 times negative 4 is a negative 16. I think I messed up here. This ain't a plus sign here. It's supposed to be a minus. So minus negative 16 all over 2. So a minus and a negative give me a plus sign. That's where I messed up. So we're at 5 plus or minus square root of 25 plus the 16 over 2. 5 plus 16 is 41. So we're going to have 5 plus or minus square root 41 all over 2. So that's choice 2. Now you could have guessed that right from the beginning by knowing when you got to do the negative b, that you get a positive 5, and the only one that's showing a positive 5 is right there. Okay, I just wanted to show you working through the whole thing. 22. The following table shows the heights in inches of the players on opening night roster of the 2015-2016 New York Knicks. The population standard deviation of these data is approximately, all right, so on this one, you got to go type everything into your stat. So you go to stat, edit. Okay, under L1, I already worked through it. So under L1, you're going to go ahead and enter each one of those in, making sure you're accurate. Okay, so we got 84, 80, 87, 75, all the way down, and you'll see that there's 13 of them. Okay. After you're through entering those in, you're going to press stat, calculate, and it's a one variable statistics question because you only have one row. So you press enter. I'm going to make sure L1 is listed there. Go to calculate. And it gives you a lot of information. Okay, the X with the bar on top, that's your mean or your average. Your standard deviation, your S of X, that's your sample set. The one that's got like a 0 with a line over it, that is your population standard deviation. So when you round it, that's going to be about 3.5. So that is your answer, 3.5. All right, next one. It says a population of bacteria can be modeled by the function f of t equals 1,000 times 0.98 t, where t represents the time since the population started decaying, and f of t represents the population of the remaining bacteria at time t. What is the rate of decay for this population? So remember, the decay formula is going to be the initial amount times 1 minus the percent as a decimal to the time. Okay? So if I'm looking at the population decay, this is the decay part, and I go 1 minus the 0.98, and I'm going to get the 0.02, which would be 2%. So it's decaying at 2%. All right, last question for part 1. Says bamboo plants can grow 91 centimeters per day. What is the approximate growth of the plant in inches per hour? All right, so inches per hour they want. So they go 91 per day, so they have days and hours. Those are not the same time frequencies, so at the end when I'm done solving this, I'm going to make sure I want it in the right spot. So we're going to go to our reference table to find our conversion of inches per centimeters. So it is there. It says 1 inch equals 2.54 centimeters. And in this question we have 91 centimeters. So we want to know what the inches are, and that's going to be in per day. So we cross multiply and we get 2.54x equals 91. Divide by 2.54 to solve for x. So I go 91 91 divided by 2.54, and we get 35.826, so on. Now right away you're like, oh, there it is. No, because this is per day. We want per hour. So how many hours are there in a day? There are 24 hours in a day. They expect you to know that. That is not on your reference sheet. So now we're going to take your 35.826, divide that by 35.826, divide that by 24, and you're going to get 1.4927. So when you round it to the nearest hundredth there, 1.49, which is choice 1. So that's part 1 on this exam. I thought this was a very difficult part 1 for a Regents exam. Normally when that happens, parts 2, 3, and 4 get a little bit simpler. I guess we'll find that out when we go ahead and do the rest.